This is an example of the search feature. So you enter a term or a phrase, inspect the results, and you can modify the search if you'd like. When you find the answer that best matches your search, the software lets you review the question, and then you can look at each of the individual answers. And again, the questions and the answers, if they've been transcribed, are completely searchable, and you can watch the entire video with transcripts, notes, and attachments in the video library.
I'm here in the rapid prototyping lab and I'm working with this rod of ABS. Now I encountered an issue when printing this rod because the length of it allowed it to be flimsy, and what that meant was that when I tried to take it off the tray I was actually cracking the piece because there wasn't enough rigidity within the piece to take it off the tray. So what I ended up doing was increasing the diameter of the back end and actually putting this plate onto it, because that allowed the software to add more base material underneath the rod, which made it more rigid on the tray. So it came off easier, it came off without cracking. The issue with this is that I ended up using like 4 times as much base material as I needed to. So I was hoping that you guys would have some suggestions on how I could have gotten the rod off of the printing tray without using extra base material.
Hey Nate, this is a problem that a lot of people have come across. While your solution was very innovative, I think that another solution you can use in the future is to put both the base plate and the material into the lie bath as a whole. That way it's easier to separate and you just have to pull it out of the bath. After a couple hours, the base plate is reusable after you've dunked it in the lie bath, and I hope this helps.
Hi Nate, I've broken ABS parts before because of the exact same problem you're experiencing. And what I ended up doing was just using a pair of thin needle nose pliers to break the support material between the part and the tray. And I was able to then get the parts to come off without breaking. So, you can try it out, and I hope it works for you.
Hey Nate, so there's a setting in the software that actually allows you to change the pattern density of the base plate, and if you lower that, it should prevent it from cracking when it comes off the tray.
Personal protective equipment, or PPE, is the key to keeping injuries from happening to yourself and the people around you. These are the SOP 123s of personal protective equipment. In this knowledge book, we will talk about 1. A trick for keeping clean while safely using cutting fluid. 2. An idea to keep you comfortable all day. And 3. A way for unprepared guests to safely enjoy the machine shop.
The standard operating procedure for PPE states that no gloves shall be worn in the workplace. The exception to this is surgical gloves. This is because surgical gloves rip, therefore you will not be degloved.
After 5 years at this facility, my favorite thing to tell new hires is to think about investing in a pair of prescription safety glasses. Not only do they promote comfort because you don't have to wear 2 pairs of glasses all day, they also help with safety. You're less likely to take them off, and they're more likely to fit your face for better shielding. I hope this tip helps you.
So there's nothing worse when somebody comes in to tour our facility, tour our building, see what we do, and they've completely forgotten that they need to wear closed-toed shoes. I mean, it's obviously a very important safety measure. We can't let them see any of the machines without, closed-toed shoes. If they're wearing sandals, we just can't do it. So one of the things that I started was this neat idea of a shoe rack, where we would just gather a few assorted pairs of shoes that we could give out to visitors who maybe wore sandals or who just didn't wear any closed-toed shoes. And that way they can see the facility, they can see all the things that we do, and not have to come back at a later time. And so by maintaining this shoe rack, we can not only provide sort of safety measures, but just enjoyment for our guests.
I have to mill an uneven chunk of material. And what that means is I can't put it in the vise. So I had to think of another way to fix it. And I ended up drilling through the material and getting this block of aluminum and drilling through it as well and mounting it to the bottom of the material. And what this allowed me to do was clamp down the aluminum and get a 0 point off the bottom of the material and treat it as if it was fixed. That was my solution. The issue was that it kind of destroyed a section of the material because I drilled through it, so I can't really use that section anymore.
My suggestion would be to use a 3 or 4 job fixture in order to keep the part steady as you work.
Hi Nate, a soft jaw fixture would have allowed you to hold the material without sacrificing any of it. The fact is this has become a bit of a common problem at our facility, and I really would recommend that we have an in-service day to teach all of the technicians how to properly set up a soft jaw fixture. I think it's really important, and I think we need to take that step.
Hey Nate, I'd recommend using a modular fixture. This allows you to build around the material and secure it so that you don't actually have to sacrifice any part of the material, and we actually have one located in the large machining room.
Correctly closing the machine shop can not only prevent damage to the large and expensive manufacturing components that are located inside, but to our company's most important component, you. These are the SOP 123s of closing the machine shop. In this knowledge book, we will talk about 1. A commonly missed procedure in the machine shop. 2. A procedure with possible severe consequences. And 3. Something they don't tell you in the SOP.
One of the standard operating procedures for closing the machine shop at night is to make sure that we turn off all the machines. Now, this may seem kind of like, why is he telling me this? Well, it's actually something that's really easy to forget, and I personally have forgotten before. However, it's important to remember because it maintains the longevity of the machines, as well as prevents things like fires, because a lot of the wiring can get hot if it's left on all the time.
So it probably goes without saying that leaving yourself logged into a computer is a security risk, not just for the company, but for yourself. By leaving an account open, you're allowing machinery to be used under your name and your identity. People can log hours on a machine, and ultimately that just leaves you exposed. So it's a complete risk to your identity, to your integrity, to your good name, and you just don't want to leave that opportunity. So just make sure you log out every night before you leave. Make sure you shut down properly, and you'll be good to go.
The SOP states that all lights must be turned off during closing hours. However, my team came to the conclusion that leaving on one set of lights in each room during the night encourages not only safety for facilities who have to come in and out of each room to clean in the middle of the night, but it also discourages theft and vandalism.
When I got in this morning, I found out that the solder paste dispenser on the micro mill wasn't working. It needed to be repaired. And what that meant was that I could still mill out PCB boards for our deliveries today, but the vias need to be connected by hand. So I ended up milling the boards like normal and trying to connect them with our solder paste. And I was getting conductivity between traces, which I didn't want, and I wasn't able to be accurate enough not to get it. So I ended up milling all of the extra copper material off of the boards, and that made it a lot easier to just form the vias and not get conductivity between the traces.
There are many PCB mills that do not apply via material to the PCB during its building process. One way to get around this problem is to take the PCB material out of the machine after the traces have been routed, but before the holes have been drilled, to apply a protective tape to both sides of the PCB material, then place it back into the machine to be drilled out. After this process, you can spread conductive material on top of the board and over all of the holes, then use a vacuum nozzle to suck all of the conductive material through the board, thus creating conductivity on both sides of the board. Then you can remove the tape and you should have a finished board. I hope this helps.
Hi Nate, in my experience with the PCB mill, I've never been able to reproduce conductive pathways as consistently as the machine can. For instance, last summer when the dispenser stopped working, I took it upon myself to call all the orders and explain the situation to them. And basically I gave them a choice of having the board shipped without vias at a discounted price or having me connect them by hand. They all were very understanding of the situation, and I overall felt like it improved our reputation as an honest shop. So try it out and see if that works for you as well.
Hey Nate, I think a pretty easy way to get the thermal paste in the via is if you just stick that thermal paste on a wire, like say the end of a resistor or something, and you put it in the hole and pull it out, it should stick in there, and that would prevent you from needing to reprint